Hello everyone, I hope you're doing great. In this tutorial, I'm going to show you all the things that you need to know about mediation analysis and its difference from moderation analysis. As you can see, how we can actually run different tests to test the effect of a mediator on a dependent variable. We have three tests that I will show you. We have first the Barron and Keynes method of 1986. So this is an old method along with the Sobel's test. And the second method I'm going to show you is the bootstrapping method, or what we call process Hayes macro by Andrew Hayes. So this is a recent book or third edition about mediation moderation along with all the models at the end or appendices. Scroll down to them with different mediation and moderation models. We have up to 99 models, so to speak. Okay, then the last method is using AMOS or analysis of moment structure to get the model. So let's start with the first section, which is the distinction between mediation and moderation. So mediation here, this model is about mediation in the sense that we have the impact of motivation on achievement. That is, the higher motivated the students are, the more or the higher the scores they may get. But this is not true because motivation does not directly impact achievement. This doesn't mean that if I am really motivated, this means that I'm going to get higher grade. No, because I am motivated, I will spend more times studying. So study hours. So because I like what I'm doing, because I'm motivated, for instance, so I will make a lot of efforts in general, be it in terms of study hours or anything that you want. And then motivation will impact study hours, and motivation along with study hours will impact achievement. So this is the mediation model. Okay, let's check now the moderation model. As you can see here, moderator variable is known as W, and it's used as an intervening variable, so it's not independent from the rest because it's in between. Okay, so this is the moderator. If you see the model of mediation, you can see that mediation is separate and it does not intervene this relationship or this direct path, so to speak. Okay, so this is the difference between moderation and mediation, visually speaking. The second section is devoted to like the way we can run mediation analysis using this method of Barron and Kenny 1986. This is a highly cited article. If we look at its citation, it's from here. You can see that this is really highly cited article, and you can just download it and read it by yourself. Then let's try to apply the Barron and Kenny's techniques to mediation. So I have another website just to help you see the techniques here. So the independent variable should predict the dependent variable. So this is like path A or or path C, so to speak. So we have motivation should predict achievement, and this can be tested using a regression test. Let's do this on SPSS. I'm going to go to Analyze, open Data View or Variable View, doesn't matter. Go to Analyze, and then we go to Regression and Linear. And then I will move the independent variable or motivation here to the independent list and achievement to the dependent list, and I can keep everything like this, or for options I can choose some stuff to be included for statistics in case I want to test some assumptions, okay, like collinearity, etc. So let's assume that everything is met. We click continue and we click OK. Let's wait for the output. So here is the output, as you can see. So there is a statistically significant impact of 56% or positive correlation, or 31% of motivation on achievement, and this model is statistically significant according to the ANOVA table. This means that the model fits the data, and this is the coefficient. So this first assumption, like path C, is assumed. So I'm just going to include the beta here, for instance, enter the number. Then the second step is let's test the motivation on impact on study hours, like the x variable, the predictor variable, or the independent variable on the mediator. Sorry, this is the mediator, not the out. This is the outcome variable. This is the mediator. So let's do this using again regression, and go to analyze, go to regression. Where is it? And then linear. So let's change just the achievement. Let's replace it by what? Study hours. The mediator, click OK. Again, there is a statistically significant change, and the model fits the data according to the ANOVA table 47. So this is, again, there is a statistically significant impact of motivation or the IV on the mediator variable, which is good. Okay, so this is the beta. I can report the beta here. The second step is we need to enter the whole model. So we are going to go to regression, and we are going to enter the motivation along with, so let's go back to the steps here. So the independent variable predicting the mediator. So this third step or second step is fulfilled. Now the independent variable and mediator should predict the dependent variable. So what shall I do here is move the study hours back to this list, and I move them to the independent list. And let's move the achievement or the dependent variable to the dependent list and click OK. And let's see what will happen. Again, there is statistically significant impact of the mediator variable along with the independent variable on the dependent variable, and the model fits the data, which is great. All these steps have been met. So we have different types of mediation, be it, let's say, partial mediation or full mediation. Like partial mediation with there is like two ways, or let's just look at the model to tell you this. So they can be for partial mediation, there can be also like two significant impacts from the independent variable to the mediator and from the independent variable to the dependent variable, or sometimes all the significant impact goes through the mediation. So this is like full mediation, but partial mediation. So the significant impact goes through the mediator, and it goes also through the direct path, this C prime or C path. Okay, so this is how we can actually test this model and can report the last one here, like when we put the mediator along with the IV. So we put it here on the DV. So this is the beta coefficient. So this is in short how we can test the mediation effect using the Barron and Keynes approach. We can use the Suball test. We just go to any browser, look for Suball test, and we enter the coefficients, and it will give you the results. So this is straightforward. I'm not going to deal with it here. You can just deal with it by yourself in case you are using this old technique. The second technique that is very easy or easier, we're going to go to analyze and regression, and then we are going to go to process V4, for example. It can be V5 depending on the version that you have, by Andrew Hayes. So there is just one author. Yeah, by Andrew Hayes. So to do this analysis, you should first install what we call the process macro. So this is the add-on folder. You can install it for R, for SAS, and for SPSS. You can download it from this website. It's called Process Macro. I can leave the link below, and you can install or download first the process macro and install it by going to SPSS utilities, like local extensions or utilities, and then you can install custom dialog, etc. by looking for it. I can even include a video on how to install that. So once you install it, you will have it. Try to apply this technique. We'll go to analyze, regression, and then process macro, and let's move the x variable or the independent variable into this list, and the y variable or the dependent variable into this list or this box, and then study hours as motivator or as mediator, they can be put here. You see, so this is like the mediator. For the model number, we can choose model number 4. Where are you going to find these numbers? Remember, I shared with you a book that contains the 92 models. It's here. So this is Introduction to Mediation. So you can see that there are different models. Where are they? Like we have model number 4 or 5. So this is like the model. So this is the model that we have. You can take it from here. So it depends on which model you have according to your data set. You can choose the model that you want. So once we choose the model, what we are going to do is we are going to just check some assumptions like, so here show total effects for models. Sometimes we can generate code for visualizing interactions, and this can be visualized using the syntax mode. And then we can even include, if we have dichotomous variable, we can include here like all continuous variables that define, all variables that define products, and the conditioning value, we can choose this value for instance, and Joe Johnson name and output. So there are different options that you can choose so that you can run the test. It depends on what options you need to choose. What I need for the time being is just these two options. So let's click continue and click OK and wait for the output. It will take some time depending on the speed of your processor because it uses bootstrapping techniques. So this takes a little bit of time. We have this problem. Variable names should be no more than 8 characters in length. Good that this problem has shown up because you may encounter it. What we can do, we can just go back here and we are going to shorten the names of the variables. Like motivation, we can include just MO. Study hours, we can include just STU. And achievement, we can just include ACH, for instance. And we go back to here and process macro, click OK, and let's wait for it again, and it will show up at the end. It won't show up again, so we're just following all the instructions that are posed here by the output window. Here we go. Yeah, this time it shows up. So you can see the significance level of different outcome variables. For the outcome variable, for the achievement, for the, so there are different paths here, and you can take their p-value, the upper and lower confidence intervals that should not cross 0 or negative. So they should not cross 0, that so that they be marked as significant impact. So this is in brief how the model looks like. Sometimes you may get a code for visualization or for visualizing the results. This time it does not show up, but you can get it. So you can just double click and copy and paste it to the syntax. Like you can just copy it, you go to file and then syntax, and then you paste that so here, where is it? Yeah, it's not open, it's no. And we go to syntax, and here we paste, for example, the code, and we just select everything. I click run, and it will be run. But it won't work for this one. So I'm just showing you how you can open syntax and run the model for visualization. So this is in brief the bootstrapping technique. The third and the last technique is using AMOS. So you need to have AMOS, analysis of moment structure software, installed so that you can run this analysis. We go to analyze and we go to IBM SPSS AMOS. You won't have this option unless you have the AMOS software installed into your laptop. So once you click on it, you wait some time, so it will show up. So once it is shown up, what we can do is that we can just draw this model here. So we can here start drawing. So we can go back to AMOS. I close this window because I opened two windows. I will start drawing. I will start drawing the same model that we have here. We have this is like the IV, this is the DV, or we can, without drawing a lot of things, so that we they should be kept symmetrical, we can just do what? We can just move objects, or we can duplicate objects. So we can just duplicate them like this. We can select everything, select all objects, and we can move them so that we can make them centered in this document. And then we can deselect and we run the paths. So we are just drawing the model that we have. So the A path, the B path, and the C path or C prime path. And then we can just take this magic, this magic hand. So just need to move this again, draw this arrow from here and take this magic hand. Let's try to fix it a little bit. I can move one variable to make it symmetrical with it like this. Okay, so now I think it's nice. Then we can draw some covariances, or we draw some error term first, then we can name unobserved variables. So these are the error terms. And then I can include the variables here. So I can just double click or I go to this file and then, or this icon, and then I will move. So I will just draw the same model. So we have motivation, drag it and drop it here. Again, we have achievement, and there for this for attitude, it should be named not attitude, but should be named as achievement, or the other name, or study hours. Yeah, study hours, not achievement. So there is difference between the variable name and the labels. So it's study hours. So once we do this, we can again take the magic. So once I have the model like this, the next step I need to do is we can draw the paths, like the coefficients for path A, path B, and path C or C prime. So to do this, we need to go to this icon, analysis properties, click on it, and we go to output, because there are different sub windows, bootstrap, permutations, random, title, etc. So we are going to go to output, and then we need to take the indirect, direct, and total effects. It's like bootstrapping, and then the standardized estimates, so that I can have them shown on the path or the arrow, so to speak. So click standardized estimates and close this window, and then so once I checked what I would like to have in the output, so I will go to the calculate estimates, click on it, and this icon will turn to the red color, and we can double click on it, and you will get the coefficients. So you can see that there are 46% of the impact of motivation on study hours, and there is this 46% has increased to 71% when we consider the role of study hours as a mediator uh, on the achievement, because not so this means that it is not motivation that impacts achievement, but it is the fact that motivation impacts study hours, and in turn motivation along with study hours impact achievement. So this is how we can interpret these results, and we want to see whether these impacts are statistically significant. In this case, we need to look at the output. So there are different windows here. We can just select a view text. Uh, this is like this view text. It will give you the different types of analysis, and it will tell you even the impact of each variable on the other. As you can see, the p-value is like statistically significant with regard to the three paths, and this is really telling. So here in this case, we have partial mediation as I told you earlier, and we can just copy this table and paste it to our output. Or so this is how we can copy. So if you just click there, you will get the interpretation quickly. When M, that is motivation, goes up by 1, the achievement goes up by 0.39 or 399. So this is the interpretation you can. This is what is good about AMOS. You get the model and you get even the interpretation along with the table. So how can we copy this and paste it into words? Using AMOS, we can simply snip this model and paste it into Word. So you can just use the snipping tool for the for taking pictures. So we have snipping tool, and then so this is you just can take screenshot and edit it in the way you like, because my laptop has become slow as a lot of apps are open at the same time. Anyways, I hope that you get the idea now. There are the 3 techniques. Tell me, which technique would you prefer the most to test the mediation effect? Would you like the Barron and Kenny's technique by running different types of regression tests? Or would you like the bootstrapping method by Andrew Hayes using the process macro add-ons into SPSS? Or would you like the SPSS AMOS, that is analysis of moment structure, and to test the model, and it will give you different paths at the same time, and even the relationships, and more than that, the interpretation one, you once you just hover your mouse over each path. So tell me this information in the comments below. I hope that this video answers all your queries. For Likert scales here, we reduced them into different items, like we computed their mean scores and we reduced them into single variables. So this is what we call the measurement model. We can run confirmatory factor analysis, and we also have what we call the structural model. In this case, we have a structural model in this scenario, but the measurement model tells you, for example, the different items separately that fall within motivation, because here motivation is measured on a Likert scale, and it has multiple items whose mean score was calculated after testing the reliability, validity, and everything, so that we can just compute their overall mean score. And there are many videos on how you can test the reliability, improve it if it's not good, and how you can test the, let's say, or you can just summarize one or compute the overall mean score. There are many videos on this. You will find them in the channel that you are watching now. If you have questions or remarks, do not hesitate to post them below or contact me via one of my social media platforms. Till then, see you in another tutorial, and bye for now.